All right, guys, welcome to another KevCAM night class tonight. Tonight we got something a little different, kind of throw a little wrench in the class tonight, and I have Mr. Scott Neal helping out tonight with us. Scott, are you with us?
I am. Good evening, everybody.
All right, so what we're doing tonight is Scott Neal, in his prior life, actually owned his own business and did a lot of molds and using HSS and HSM with SolidCAM to do all his molds. And so what I wanted to do is kind of, as a HSS wrap up and HSM wrap up, kind of bring him in and go over some of the parts that he's done in the past, and kind of some strategies. We'll kind of cover some strategies that why he chose those strategies, and little maybe tips and tricks on why he chose that versus other toolpaths and stuff like that for you guys. So just kind of using him as kind of like an outside source for you guys, and someone kind of looking on the outside in, and maybe something that I didn't cover in there, and kind of give you guys a little different change pace. So every once in a while, what we'll do for you guys is bring in a special guest. Now, let me ask you guys this. This was kind of brought up by the CEO, Sean Maimutis, and what would you guys be interested in doing a night class with Sean and convey any ideas, suggestions, stuff that you'd like to bring up to the CEO of the company and in a live webinar night class, I guess? Okay, I'm getting some yeses. Okay, excellent. So we'll bring him in here one of these days. We'll drag him out of bed down in Florida, and I had to drag Scott out of bed tonight to do this one. But for those of you guys that are new here, oh, go ahead, Scott.
I was going to say, yeah, we go to bed with the chickens here in the South.
And if you guys can't tell, Scott's our good old Southern boy with a good old Southern accent.
I'm not the one with the accent, though, Kevin.
Yeah. All right, guys. So for those of you guys that are new, I do see some new faces in here. We do use GoToWebinar, and this is kind of the best way to convey any information over to you guys. And so right now, currently, everybody is in mute, and that's just to eliminate any background noise. And if you guys do have any questions, which I definitely encourage you to do, write those into the chat, and we'll get those answered right away for you. Like I've said in the past, these classes are solely dedicated for you guys as a learning tool, and trying to get the most out of it as possible for you guys. So if you guys do have those questions, let me know. And then I feel bad because I bring this up in every night class, but for those of you guys that are new, if you guys have an idea, definitely send them over to me, and we'll either do a whole night class on it, or what we'll do is make a quick little 5-minute video on it. So a lot of you guys have sent over those suggestions, and send them over to me, and I just put my email address in there for everybody, so you guys can have my email address and email those over to me. And then another thing for those of you guys that are new is we record every night class, and then all those quick tip videos that are on the YouTube are right here. So if you guys go to YouTube, type in KevCAM or type in SolidCAM University, my ugly mug will pop up for you guys. And we have tons of helpful videos in here to help you guys along, and not just with machining. I did a kind of unboxing with a 3D connection mouse, doing some testing with a different tooling here. If any of you guys are interested, this is the live cut we actually did last Wednesday. We were cutting 304 stainless steel, doing a goggles mold. And I do have this one just kind of hidden right now, but if anybody would like that, let me know, and I can get you guys the link for that video. And pretty cool video, and just kind of more of just showing what iMachining can do. This is actually on a Herco VMX42 HSI, so pretty nice machine there. But yeah, so if you guys come to the channel, hit the little search right here, and you can actually search through everything in here. There's getting to be quite a bit of information in here for you guys, so you're going to have to start using that search just a little bit more. But more than anything, if you guys do have a video that you're looking for, I know, Tim, you were asking about a video today, just shoot those over to me, email, and then I can get you the direct link. And between myself and Mark doing a lot of these videos, we can usually dig them up pretty fast for you guys, so, and send those off to you. So, so I guess with that being said, well, I assume everybody can see my screen. So with that being said, let's kind of get over into the HSM side of things, and we'll get going with the HSM and kind of see the strategies that Scott's used over the years and some of his favorite toolpaths. And it's funny because, you know, we kind of look at Scott as our mold expert at SolidCAM. So, you know, we'll bounce ideas off him and stuff. And some of his favorite toolpaths has turned into some of my favorite toolpaths. So we'll kind of cover those for you guys. But all right, Scott, let's switch it over to you, and let's see what you got.
Okay. All right. Thank you, Kevin. And hopefully you guys can see my screen. Should be seeing a SolidWorks with a cavity insert in it.
Yep.
And you see that, Kevin?
Yep.
Okay, good. I'll just give you just a quick background. As Kevin said, I've been in machining for quite a while now, almost 40 years, and about 30 of that has been in doing injection molds. Over the years, I was actually using SolidCAM as a customer before I came to work for SolidCAM. And as a customer, Kevin was actually one of my tech support guys, so I used to rattle his cage once in a while with some questions.
Those were the calls that I cringed.
No, Kevin. Kevin always did a good job and answered most of my questions or pointed me in the right direction anyway. But this is just a simple cavity to get started. This was just a little small boot mold made out of a Sanaprene, molded out of Sanaprene material. And like I say, we only have a few tool paths here because that's really all it took to do this. 3D machining for roughing it out with a, I think it was a 1/2 inch, 60 thousandths corner radius bullnose end mill. Yep, that's what it was. And the machine that I used was actually a Haas VM3, which is basically the same as the Haas SS, had the 12,000 RPM spindle and the high-speed machining. So, you know, I know a lot of you guys, I see some familiar names on the list here that I've talked to over the last couple of years on tech support. So most of you guys are familiar with some machining, so I'll kind of forego explaining that. But you know how machining works. Do you have something, Kevin?
No, I was just to say what. So with iMachining, the 3D iMachine, you know, we have our default scallop. Do you find yourself, or you know, back in the day, were you finding yourself changing that scallop height in the 3D iMachine?
Actually, I did. If we look over here in the technology, I actually took that down. I think default was 83 thousandths, and I wanted a little bit finer scallop for doing my finish pass, where I could forego the semi-finish pass and I could just go straight to the finish. So I just left a 30 thousandths scallop and then a 15 thousandths wall offset and a 10 thousandths floor offset to finish this bottom floor, which was actually flat. And that left me a pretty good semi-finish. And if we just kind of run through a solid verify here, you can see that we'll have a pretty decent scallop on it whenever it finishes with the 3D machining. I think there's maybe one step up here on the wall, but down here where this big fillet was on the bottom, it looks pretty good. And the tools I used for finishing was a 1/2 inch ball up, or actually that same tool, the 1/2 inch bullnose. And then I used a 1/2 inch ball on the floor. If any of you guys do any injection molds, you know finish is critical in injection molds. So instead of just doing taking a flat nose or a bull nose end mill to do a just a contour or a pocket on this bottom surface, I actually wanted to surface that and give me a pretty fine scallop height, so I would get a finer finish on that top of that part or the bottom of the cavity.
Now, as you were, you were using a lot of bull nose end mills. We had some, I think it kind of came up when we were doing the HSM series from a couple of customers. Do you have any suggestions on, manufacture of your bull nose end mills? Was there a better one that, company that worked better or got better tool life out of?
This particular mold, and most of the molds that I did, cavities and cores, were, I did a few out of aluminum prototype tools, but most of them were P20 or a 17-4 precipitation hardened stainless, some H13, maybe an S7. Some, we'll call them the cheaper tools, we did out of 4140 preheat treated. So everything was pretty, I won't say real hard, but anywhere from maybe 28 Rockwell C up to maybe around 50 or 55 Rockwell C for wear for certain materials. So I always tried to use premium tools like your OSG, Yabro from Seco, Carbaloy. They're really good end mills. Let's see, I use some YG1s, just kind of a I guess the flavor of the day kind of thing. Sure. As far as salesman would come in, hey, we got these new end mills, this new line of end mills, let's try this. And for the most part, they're all pretty similar. I could run some of the, like the OSGs and the Yabros, I could run those. They would last a little longer. I could run them a little faster as far as the surface footage.
Okay. Now, how about coating? Were you running?
Just mainly
TIN or?
Yeah, mainly ALTIN,
okay.
Aluminum titanium nitride. Those seem to be the harder coating and the best wear. Most of this material I ran dry with just an air blast just to keep the chips out of the way, keep from recutting the chips. So really the ALTIN coating really thrived with the heat that was generated with the surface speed that I was running. And most of these carbide tools I would run somewhere in the neighborhood of 600 to maybe 750 surface feet per minute. With a half-inch end mill, that's somewhere between maybe 4,700 RPMs to 7,500 RPMs.
Okay.
So the wear was, with that coating, the wear was pretty good. I could generally get through semi-finishing and finishing tool pass with one tool, depending on the size of the cavity and core. Sometimes I may have to change over if it was a bigger cavity, in the 24 by 18 range, somewhere around in there. I may have to do just half of it and then change the tool and just do the bottom half with another tool.
How long of Ronnie's asking how long of a cut time or life that is? Let's see.
Probably in the neighborhood of I could probably get maybe 6 to 8 hours of finished cuts with one tool.
Now, and that was mostly with a bull nose that you were running, or would that be?
That bull nose and ball nose, and most of the time, if I was doing more vertical wall stuff like this cavity is mostly vertical. I would use a bull nose because I could get a more constant surface footage on the cut around the peripheral of the tool. Now on the bottom, I would use a ball nose just because I didn't want that swirl that you'll get with a bull nose or a flat nose end mill on a flat surface. And that's why I actually use this 1/2" ball to do this toolpath on the bottom.
Okay.
Makes it easier to polish out. So for the finishing toolpath, one of my favorite is the hybrid constant Z. Now, you know, with the constant Z, it's just a constant Z step, and then it takes a slice through the part and profiles that contour. With the hybrid constant Z, it does that in the passes and does a step down. But with the hybrid, what it'll do is the more horizontal surfaces, like down here on this big fillet and up here on this big fillet, the more flatter or horizontal surface, it would 10,000 step down would be a much bigger step over. So you'd have a bigger step here. So with the hybrid, what it does is it comes back, and in between those steps there, it looks at this step over and says, okay, if my step down requires me to step over past 5 thousandths, then I'm going to reduce my step down, and whatever that comes out to be, that's where I'm going to go with my constant Z step. So if we just take a look at this, you'll see, excuse me, you'll see this area up here, the more flatter area, where we have a lot more steps. And that gives me a better finish on that flatter surface, or on that fillet as the tool rolls over the surface. And if we go through a quick solid verify on this, we'll be able to see that. Let me go ahead and speed this up a little bit. You'll be able to see in the beginning the bigger steps over.
That looks like you did kind of is this a zigzag, or were you doing a spiral?
No, this is just a standard constant Z.
No,
you just don't see the...
Are you doing a one-way or zigzag?
No, it's a one-way.
Okay.
Yeah, I always, especially on cutting on the peripheral of the tool, always try to do a climb mill. It gives me a better finish and a little bit better tool life as well.
Now, while this is playing through here, on a particular part like this, what would make you want to choose your HSM versus HSS?
Just because I didn't have to go in and pick all the faces that I wanted to cut, I could look at the whole target, and what I did on this one was I selected a boundary, which was the edge of the cavity.
Sure.
And that way I just worked inside the cavity. It just basically ignored everything else on the outside of that. So you can see on this vertical wall how we got a pretty decent scallop height. But up here at the top of this radius, we've got a pretty wide step over. And let me change the parameter here, make this run a little bit faster. We'll crank this up to 50. And let it run a little bit faster, get through this. Because it's pretty consistent all the way down this part. We get down here to this bottom fillet, it'll do the same thing. But what I did on this last one with the 1/2" ball nose is had it come right up to that fillet, so it smooths that out pretty good. And we're getting close to the bottom now, just a few more passes here. And it'll actually, in the bottom part of this fillet, it'll kind of smooth that out a little bit as well.
This is what kind of boot cavity?
I'm not sure what this boot was for. It's just a rubber boot for a shaft, some kind of shaft. Okay. You can see how it's coming back and recutting those areas and smoothing out those scallops up on the top of that flange now. That just gives it a more consistent step down and a better finish. And I don't know if any of you guys that are with us tonight do any injection molds, but polishing is a pain to do, and I always hated it, so I tried to get as much done on the machine as I could. So that's a pretty consistent finish all the way down that cavity wall.
All right, so Ronnie's asking, that seems double the published data. How'd you come up with these speeds, and what about inches per tube?
For the, okay. Rule of thumb that I've found over the years for, let's go back here to the tool. If you'll look, I'm running about 650 surface feet. The tool vendors generally post data conservatively, and I've found through trial and error, just because of I know you guys have probably been in a situation too where the boss comes and says, hey, I got to have this before you leave today. And with me not wanting to stay to midnight, I'd crank everything up so I could get it done and get out. So by doing that and then noticing, okay, I didn't get that much more wear off the tool, that's just some of the numbers that I came up with over the years. And as far as the inch per tooth, what I discovered through some research and talking to some different tooling vendors, especially with ball nose and the cusp height or the step over, their rule of thumb suggestion was if you had a let's say a 20,000 step over with a half-inch ball, kind of calculated out to a maybe a 1/10 cusp height. So to maintain a consistent cusp height both ways, as far as the step over and also the step into the tool path, that general rule was like half of the step over would give you pretty much the same finish for your inch per tooth for your feed Z here. So I think this tool cutting, I think the cusp height down these steps came out somewhere in the neighborhood of about 50 millionths, somewhere around in there. And this was a 10,000 step down. So I just translated that over to a 6,000, basically 6,000 step over per tooth. So that gave me a pretty smooth finish. Didn't have a whole lot of polishing to do there.
Okay.
And go ahead.
Definitely, guys, keep the questions coming, because now's the time to pick the brain. So.
Now on this bottom, again, this is a flat surface, and instead of doing just a pocket operation using this edge contour, I actually did a spiral machining on this one because it would be a consistent step over, so it would give me a consistent cusp height throughout, so it made it easy to polish. Again, I just selected the constraint boundary. Let me show this, and that's just the part here, just so it would stay in there. And on the passes, the center of this cavity was in the center of the block, so my XY center was 0, 0. Started at a radius of 0, and the max radius is actually this edge of this, the bottom of this fillet.
So that's how you contain it, just to stay within that area then?
Right. I just told it to start at a 0 radius and go to this radius here. And again, with HSM, I just told it to, not go any further than this minus 1.25 depth, which is the bottom of this cavity.
Now,
go ahead.
Well, I would just say, out of curiosity, or just for myself, I would think, using a flat end mill, would give you almost a just as good of a finish versus doing a spiral like that. And you said it's easier for polishing. Can you fill myself in on why I would use a ball end mill versus a flat end mill for down there?
It's mainly for, and again, this is experience. If you use a flat end mill or a ball nose end mill, this basically has a flat area on the bottom. You have a clearance angle on the bottom of it. Well, that clearance angle is very minimum, maybe half a degree at most, probably. So if for some reason a chip would get hung up underneath there, that would drag across that surface and scratch it. So I know everybody's seen the pocket style. When you finish the bottom of a pocket, especially in a softer material like 1018, you'll see these swirls every once in a while, and especially in the direction change. And that's one reason you get those swirls. And when you're doing cavity and cores, again, like I said in the beginning, surface finish is critical. Some of the, especially if you're doing something with a clear plastic, those are highly polished, and you don't need any. A swirl would be basically considered a gouge, and it's not from the tool, but it's from a chip dragging across and scratching a deep scratch in the bottom of that. So that's the main reason I use the ball nose for, and I did that for not just these type of just circular flat surface, but a lot of other surfaces that were part of the surface of the part that was going to be molded, that was cosmetic, where people were going to see it.
Gotcha. Now on this particular part, I got a question came through. Were you running the 3D machining dry, or did you run coolant with that? I would assume you did air.
No, I did air blast on that. Again, the tools that I used, the carbide, the ALTine carbide, running at the high feed rates that I did, it was recommended from the vendor to run dry. If you run coolant on these carbides, they could go into thermal cracking, which means when you're in the cut, the tool heats up. When you come out, the coolant splashes on it, cools it off, and then it goes back in the cut, and it's an endless cycle. So heat, cool, and whenever you start doing that, it starts stressing the tool, the coating, and you start getting thermal cracking, and that starts breaking down the coating, which in turn starts breaking down the tool.
Sure. Now I've seen something, and if you guys want more information on it, I can get it to you. I have to rack my brain on what customer it was, but we actually had one of our customers kind of invent he didn't have air blast, and he's mostly cutting softer materials, the aluminum and stuff like that, and he wanted to be able to cut it dry, and so yeah, I can definitely dig it up for you guys, but what it is it's basically a little fan blade that's mounted to his tool. So it can still go up in the tool changer, and it's just for that tool only, and you mount this little fan blade on there. And you're showing me a comparison, with it and without it, and surprisingly enough, this little tiny fan blade was actually able to throw out all the chips and keep all the chips out of there with the aluminum that he was cutting, so he wasn't getting any recuts. So if any of you guys are interested in that, I'll try to dig up and find that YouTube video. I know he sells them, and they're fairly cheap too. For those of you guys that have maybe older machines and don't have the air blast capability, or don't want to rig up a little air nozzle on your some zip ties and air nozzle.
Yeah, and have hoses hanging down and get caught in something and snatch it off whenever the rapid moves and stuff. Yeah, that can get aggravating.
Yep. So.
All right. Yeah, that's this was a pretty simple cavity here. Just a few tool paths, and we got a pretty decent finish on those 3 tool paths. And I think the total runtime on this cavity was less than an hour, or somewhere around an hour.
What is your personal opinion on the TI ALN coating?
The TI ALN coating is very similar to the ALTIN. I prefer, now when you get into, I think that the TI ALN is a little bit more, the lubricity factor is a little bit higher. So if you're getting into, I think that coating is good for stainlesses, Inconel, stuff like that. I think they use that coating for those tools, if I'm not mistaken. But for just the standard hardened materials, I prefer the ALTIN coating.
Perfect.
All right. Well, let's go ahead and close this one out and jump over to a core. And this is not the core for the same one. This is one that we did, and this again was just another mold insert for another plastic part. And this part here is a little bit bigger. It's like 8.5 by almost 4.5, and about 1 3/4 inches tall. And again, I just used 3D I rough for roughing it out. I came back with, this was with the 1/2 inch bull nose again with a 60 thou radius, and I think I came back with a 1/4 inch with a 30 thou. Kind of work out these corners over here too, because I think if I recall, these are like 60 thousandths fillets around here. So I just wanted to get some of that corner material out before I started doing the finishing with some other tools. And we'll just run through a quick simulation on these 2 3D machinings. And this one.
On this one, did you kind of set it as a 30 thou step over, or did you just kind of change that scallop per mold depending on what you're cutting?
Well, it depends if I'm going to do a semi-finish pass on it. This one I actually did a semi-finish pass, so you can see I think I did change the scallops to 30 thou, but you can see it's much bigger step overs. So I wanted to kind of smooth it out a little more. I think this part was actually a clear part. So I had to have a much better finish on it. And again, this was P20 material. I think it was 28 to 30 Rockwell C. And that's what I ran most of the stuff that I did out of, was P20. It cuts good. It's pretty consistent as far as the finish goes, and it's easier to polish, and it's real shiny and pretty whenever you get through with it. So you can see all the scallops there on that tool path. So what I did on this one was I just combined a constant Z with the linear, and then on the constant Z, this is another one of my go-to tool paths, especially if I have a lot of horizontal, more horizontal face surfaces like this nose here, and the tops of fillets, and almost this whole area over here. So on the constant Z, I told it anything in between 40 degrees and 90 degrees, cut with a constant Z. And I just left 5 thousandths on the wall and none on the floor. And on the linear passes, I told it anything between 0 angle and 45. And that gives me a 5-degree overlap in between the 2 tool paths. And on the linear pass, I left 5 on the wall and 5 on the floor, because I didn't want it to come in and do a linear pass on this here. And this particular one I actually did a horizontal because I think this was more of a seal-off area here, so I didn't have to worry about finish. Let's kind of run through this one a little bit here. Actually, I want to show you the tool path, and you can see.
And then when you go to do that, what were you running for feed rates on this?
Feed rates on this one was probably pretty consistent with the other one. Actually slowed this one down here on the tool. This one may have been a little bit harder. It may have been maybe a H13 at about 50 Rockwell, I believe. That's why I slowed it down.
Okay.
You can see the where the toolpath changes from a constant Z on the more vertical areas here to a linear on the more horizontal areas. And just running that through Solid Verify real quick.
This is more of your semi-finish?
Yeah, this is a semi-finish with a ball nose. I think it was a 1/4 inch ball nose.
Okay.
And there's the linear toolpath, just kind of smoothing everything out.
Yeah, guys, one thing I really like about this toolpath is, like Scott was just showing you guys, you know, anything, he's got, you know, from 0 to 40 degrees set up, and then from, or 0 to 50 degrees, I can't remember what you had, and then,
yeah, 0 to 45.
Yeah, 0 to 45, and then from, you know, 40 to 90.
40 to 90, yep.
So you get that nice little overlap in there as it's kind of coming to it. Now, obviously, you guys don't want to do a, you know, you can do an exact end and stop right at 45 degrees, but there's that possibility of, you know, getting that little line going through there, so it's always nice to have just a little bit of an overlap there. So.
Yeah, and then another one of my go-tos is that hybrid constant Z for the finish pass. And on this, you can see this one actually gives a pretty good smooth finish on this as well.
Now, while this one's playing through, what make and model of tool holders are you more in love with, I guess I would say?
Well, most of the tool holders I use for end mills, especially from, let's say, a half on down, are the ER style for finishing. You know, at the time now, we're using a lot in our live cutting the Rego Fix. What is it? Power grip.
Power grip. Yep.
Yeah, those are really good. They're more hold the tool more concentric than even the high precision ER collets. But for the most part, the ER, I think 2/10 run out collets that I was using back in the day. And again, my machine was a Haas VM3, which, you know, you hear a lot of people downplay on Haas machines, but I cut a lot of high precision 3D surfaces with that VM3. Holding, you know, for 3D surfacing of seal-offs for some of these molds, you know, you have to hold better than a 1/2 thousandths tolerance, because some of the plastics like nylon are real watery type because I think the melt, the injection temperature of the plastic is somewhere around 600 degrees, so it almost runs like water. So your venting or your gas vents are, you know, they have to be no bigger than 7/10 of thou. So.
Yeah, and to kind of go to the tool holder side of things, guys, you know, we've had, you know, we get a lot of tooling companies, and Ken and Scott do a lot of our cutting on our machines, and, you know, for some of these ones, it's you know, like that Goering diver tool one, you know, it was both myself, Scott, and Ken on there, and like I said before, our goal was to kind of, you know, break that tool and see what we can actually push it through. Well, at the beginning testing phase, what we're actually running into is the tool, we're pushing it so hard. And like I said, we're going beyond the parameters of, iMachine, where we kind of went into the iMachine database and modified these parameters to really push the machine as hard as we could. And the only thing, even the heat shrink holders was pulling out just a little bit. So that Rego fix, and not a paid endorsement at all for Rego fix, but just something that we've come across and really fallen in love with is those Rego fix holders, just because there is no pull out at all, which is really nice. And you guys think a heat shrink holder definitely shouldn't be pulling out at all. But if you guys are really pushing things to the extreme and trying to get stuff pushed out the door really quick,
Yeah.
those Rego tool holders just work amazing.
Yeah. One of the things that we do with the iMachining webinars and even the demonstration we do at trade shows and open houses and stuff with the iMachining is this just basically push iMachining and the tooling and the machine as much as we can to show you that there's almost no limit to where you can go with iMachining, depending on the combination of tooling, tool holders, end mills, machine, work holding, that kind of stuff that you can do with iMachining.
Absolutely.
And then this one here again, it was just a HSM horizontal with I want to say it was a 1/4 inch bull nose. And the reason I did a bull nose too is because I had this fillet here, so I knew it could overlap a little bit.
And surface quality wasn't as crucial on that flat.
Surface quality is right, and because this was more of a seal-off area here. And I think I just threw this Toolpath on here just to give me a more consistent surface around the whole part. On top of the constant Z, this one here I believe it is, yeah, the hybrid constant Z. This one is the 3D corner offset, and it takes, especially in these areas here, the pencil pass strategy to get these vertical and horizontal, and then the angular transitions between these faces, these surfaces. So you can look here and you can see that the toolpath is actually driving around and not going up to the wall, changing directions. So it's kind of following the flow of these fillets here. You can see it transitioning around these down here as well.
Kind of following the flow of the model itself.
Exactly. And then it's recognizing the transition from this surface to this surface and these surfaces here. So it's just kind of doing this thing, flowing around, just making sure that we're not going up against a wall and changing directions, which sometimes will leave a little witness as it changes directions there. So this is a nice toolpath to get a consistent finish on a larger surface area, 3D surface area.
Now, would on this particular part, how would like a 3D constant step over do on something like this?
It would work pretty good too, but the 3D constant step over is going to, when it gets into some of these transition areas here,
do a
little bit of, yeah, a little bit different tool flow around these areas here.
Okay.
But that's still a good tool path. If you were just doing something like had this area here all the way around it, the 3D constant step over would be a perfect tool path to finish that one.
Gotcha. Cool. Any questions, guys, on this particular part right here before we jump into our last one here? Okay, looks like we're good, Scott.
All right, I got one more here. And this one was just a core. This was actually a 2-cavity mold. This area in here is a seal off all the way around in here. But this was a 2-cavity mold core, and again 3D rough to rough everything out. And I just took a face. This is a seal off area here, so I just took a face mill and ran across the top of that to give me a good flat, and I actually used the 1-pass. I took a 2-inch space mill, went right down the center of that.
Now, in your roughing strategy, have you ever found yourself using the HSR versus the 3D machining, or would there ever be any benefit that you found out?
I used to use the HSR when I first started using SolidCAM. This was before 2D machining and 3D machining. And I used the HSR a lot, the constant Z roughing, the rest roughing. 3D machining kind of took over the need for the HSR. Now there's still a couple of 3D HSR toolpaths, like the rest roughing. Sometimes you may want to do a rest roughing with the ball nose, and I use this once in a while if I have something like that. If I have like like that last one that had the small fillet. If I have something with a bigger fillet, like a 1/8 or 1/4 inch fillet, and I rough out with a 1/2 inch ball or bull nose, I'll come back with the HSR rest roughing just to kind of work more of the material out of the ball, those fillets with the ball nose end mill, just to get a smoother transition around those fillets for the finishing tool paths. This is the main one. Sometimes I use the rib roughing. If I had some small ribs that I want to put in there, and no, I don't think any of these has some ribs in it. This was actually a rib, but I was able to cut that with a 1/8 bull nose. I believe that's what I used on that one. I believe it's that tool number 2 here. Tool number, that was a 1/4 inch, and number 3 was the 1/8. So yeah, I actually did my finishing with the 1/8. So those ribs were big enough that I could get some bigger tools in there.
Gotcha.
But that rest roughing is probably the main one that I would use after I started using iMachining. Because the 3D iMachining looks at the rest material, I could just step down from a 1/2 inch to a 1/4 to a 1/8 and get pretty close to a near net finish with the 3D iMachining. Now this one I actually did a couple of semi-finish and finishing passes on. And let's see, yeah, just because I used the bigger end mill to get more of the bigger open surfaces with a 1/4 inch ball instead of the 1/8. And then the finish. And most of these tool paths are horizontal and combined constant Z with horizontal, because it was mostly almost vertical surfaces and almost horizontal surfaces. There wasn't really a whole lot of different transitions as far as the 3D surface goes. And then same thing here on the with the 1/8. I did some linear passes on this one to get some of these fillets, finish some of these fillets here on the inside. And this was a pretty simple, straightforward one as well. Then I had some engraving on this one, so I just did this with a contour, just a 2D contour, and selected the faces.
So I got a question come in here, and what's your opinion of HSS operations for finishing of molds?
HSS, if I want to do some detail work, let's say if for some reason I couldn't get you know, if I wanted to come in here in this little area here, I would use an HSS, you know, maybe constant Z to do these surfaces, these vertical surfaces here, and then maybe a linear to do these guys in here at you know, 2 different tool paths. Do one constant Z for this one and do a linear for this one. And then on these fillets, I may come in with a morph between 2 boundary curves, because that would give me a pretty consistent tool path and a nice finish on that fillet around that transition.
So I guess what you guys can, we can say is, you know, we can use HSM for, you know, 90% of it, and then if you do have some fine tuning or fine detailing on a mold, it just in a specific area, then you guys could come back and use HSS.
Yeah, that was usually my fine brush for the, you know, for the fine finishing of some details. You know, like this area in here, you could throw some HSS. Again, morph between 2 boundary curves would work perfect for that area right there.
And then what we're using for kind of speeds with those cutters, or what material were we cutting here? And
I think this one was actually aluminum.
Oh, was it?
Yeah, this was a low volume tool. So we used, I want to think we used 7075 aluminum for this one. Just because it was, you know, 7075 is a little harder than 6061.
Yeah, that 7000 series aluminum always cuts so much better too.
Oh yeah, I like cutting it. But these tools, I think I ran those pretty much at max, maybe, yeah, 10,000 RPMs. Even on the 1/8, I could run that, you know, pretty fast, 100 inches a minute, and get a pretty decent finish, because I was only running 5,000 chip load.
Have you ever tried using your CNC machine to polish?
I actually did that with and this was a long time ago. I did that with a little cavity that was it's some kind of hand poured rubber, and actually did some burnishing on I think it was a D2 that was hardened to 60 Rockwell, and I used the tool to burnish a flat floor, because it had to have a real good finish, and I think the spec on it was a 16 RA finish, and I took it into QC to check the finish on what I got, and I ended up with like a 4.
What does that tool kind of look like?
The tool that I used to burnish with?
Yeah.
Actually, all I did was I took a 2-flute 3/4 ISCAR insert mill, and I just ran the surface footage way up, and just took very light cuts, maybe 2/10. 2/10 on those inserts normally have like a 3/3 hone edge, 2 to 3/3 hone edge. So it wasn't actually getting the cut underneath or the hone edge. So it was basically just rubbing. That's just something I stumbled across, really.
Sweet. All right, guys. Any other questions out there for Scott? I know we're kind of getting close to our end of the hour here. Definitely shoot those questions over. Ronnie said, thank you for all the answers.
You're quite welcome.
Yeah, he's our mold go-to guy for at SolidCAM, that's for sure. He's got all the tricks up his sleeves and stuff like that. So, but
Well, the longer you're in this business, the more you see, the more you try, the more mistakes you make, and the more you learn from those mistakes.
Yeah, so for those of you guys that haven't seen Scott, from polishing back in the years, his knuckles are as big as can be. No, I'm just kidding.
Yeah, I got big, short, fat fingers.
Okay, so on hard material, say 50 Rockwell, how do you determine Z stereo depth? Tim, I guess, can you, okay, so on a hard material, say 50 Rockwell, how do you determine step depth?
For roughing or finishing? For finishing, really don't change anything as far as step downs. I haven't changed anything. It's all based on or my calculation of depths per step, whether it's step over, step down. It has been, what kind of finish I want on it. Now, is the harder material, that's where what you'll need to maybe take into account is the material you're taking off. The harder the material, I left less stock on. So let's say I'm cutting P20 at 28 Rockwell, I may leave, depending on, let's say I was going to finish with a 1/4 inch ball, I may leave 7 thousandths for a finish pass. But on H13 at 50 Rockwell, I may only leave 4 thousandths. So it's more of a trial and error, what kind of finish you can get with 4 thousandths, what kind of finish you get with 2 thousandths or 7 thousandths. It's more of an experience thing. I've tried leaving more material. The harder materials, the more it has to cut, the more the tool is going to flex. So just kind of keep those kind of things in mind when you're trying to decide how much stock to leave. Your step size is going to probably remain the same. You may vary just a little bit, just maybe a few tenths or maybe up to 1 thou, but most of it's going to be how much stock you're going to be taking off.
So like if you were to do a 3D eye machine on a 50 Rockwell, would you change your scallop to, or your wall offset to, you were saying about 8 to 10 thou?
Yeah, if I had the harder material, I would leave less stock on for finishing.
Okay, which makes sense. Where is that? Okay, so perfect. So another one come in here. Personal preference for you, kind of, Scott, is, I kind of think where he's gearing it for is, do you, with all the time that you spent, do you feel more comfortable with HSS, or do you feel more comfortable using the HSM and HSR stuff?
I'm actually comfortable using both. Both HSM and HSR have their pros and cons, we'll say, or have their specific strong points. Again, HSM is going to allow you to do the whole thing and work off the model. So it's doing basically the gouge checking on the whole model. Whereas HSS, you got to be careful and make sure you're not, make sure you pick your gouge check surfaces. But HSS, again, for doing detail work, doing smaller areas, I prefer to use HSS because I can define which area I want to work on with HSS just by picking the surface.
Yeah, and you guys got to think too, when you look at entire mold, we haven't gotten anything too crazy here, but you're getting, maybe 1 million different surfaces. you know, in some of these, you know, molds, you're going to have to click on all those surfaces with HSS, where with, excuse me, with HSM, you know, all Scott's having to do is throw a boundary around that, and it's fine in it. But like you said, that HSS is kind of just that fine tune. So it kind of leads on to the next one is, you know, would you say, you know, personal opinion is HSM is more geared towards the mold work side of things?
I wouldn't say, I would say that you would use HSM more, probably 75 to 80% HSM, and maybe, you know, maybe around 20%, 25% HSS, just because you're going to run into some mold cavities or cores that's going to need some extra attention for details. And again, this is a perfect example. This little area over here, especially if it's a lot smaller, you've got to use a smaller ball mill. I mean, I've used with that machine that I had, that VM3 with the 12,000 RPM spindle, I've used 12 thousandths diameter ball nose that were, I think, like a 1/4 inch cut. It might have been, let's see, what was it, 20 times diameter as far as reach goes. So I've had to cut 15 thousandths deep, 15 thousandths wide ribs, 3/16 deep with that machine. So HSS, for finishing, HSS would be perfect for that, because you could, you know, just select these faces and say, okay, I just want to cut this one face right now, and then work on these down here at the bottom, you know, with another toolpath, rather than creating a boundary around this area and say, okay, work on this whole area.
Sure. Does that kind of make sense, Ronnie?
So the bulk of your 3D work is probably going to be with HSM.
Yeah, I like how you pointed that out. You know, 75% of, you know, if you're doing mold, 75% of it's going to be done with HSM, and then 25 would be kind of finishing up with that HSS. Definitely put it in a good perspective there. Perfect. Any other questions, guys? All right, I think that about kind of wraps up everything. And Clarence said, thanks, Scott, great class. I know Clarence, it's been a long time since you talked with Scott.
Yeah, just a few hours.
Yeah, for those of you guys who don't know, Scott was actually on site with Clarence just a couple hours ago. So I told Scott he had to hurry up and drive fast to get home to do this class with you guys tonight. But
yeah, we had a good class the last couple of days. Clarence sat in on. It was 10 of them, 10 students, including Clarence. Good class.
Absolutely. And I'm going to just kick over back to my screen here. And I guess that kind of wraps up everything, guys. You know, I like to kind of throw this at the end. You know, you guys are liking the class and stuff. Tell your friends about it. We'll throw you some good cash, and you know, tell your friends about it and get them involved. But you know, more than anything, guys, you know, these, like I keep iterating, these classes are solely dedicated for you guys. So send those ideas over to us. You know, if you guys have anything that you guys want to cover, looks like we have still pretty nice class schedule coming up, going through the 5-axis stuff, and I think, you know, maybe once every couple months we'll kind of bring in you know, one of our internal guys like Ken Merritt. Ken Merritt is extremely knowledgeable. You know, he used to work at SolidCAM, kind of coming over here. Same thing with Darren Bryant, and kind of pick their brains a little bit on some parts. So, but more than anything, guys, I'd love to thank you for the time and spending the time with us at night. And like I said, these I want to gear these more towards you guys, so you guys just let us know what you want to see, and we will teach it for you. So I guess with that being said, thanks again for watching the class tonight, and this video will be posted up on YouTube probably about 1 o'clock in the morning. Scott, with those parts, if customers would want those parts, are those okay to give out?
Sure.
Okay. So if you guys do want those, just shoot me an email, and you can kind of see what Scott did and dissect it even a little bit further if you want, or just kind of use them as examples as you guys are programming parts. But yeah, I guess that wraps it up. And Scott, thanks again for your time.
And thanks for having me. Thanks for inviting me, and thank all of you guys for putting up with me for the last hour.
All right, guys, have a great rest of your week, and we'll see you guys next week. All right, bye, guys.
All right, bye.